Welcome to another math video. Today we'll talk about the forms of quadratic expressions, which also means the way of writing down the quadratic expressions. So let's start with the standard form. You might have already seen that way of writing a quadratic, which is ax squared plus bx plus c. And in this form, it's important that the a is never 0, because if the a is 0, you don't have that x squared term, which means it's just a linear expression. It's not a quadratic anymore, which is why a cannot be 0. And an example of this would be x squared plus 4x plus 3. And that's your standard form. Let's talk about the factored form next. The factored form looks something like this. You can have a factor in the front, and then x minus, for example, s, and x minus t. Or you can have a factor inside, which will look like this. Let's call it Rx. It can be any other letter, doesn't matter. Times Qx minus t. In this case, the factors are inside the expression. And most of the time, you'll notice that a is just 1, or r and q are just 1. But they can be something different too. And an example of this would be x plus 1 times x plus 3. That's your factored form. And the last one is the vertex form. And the vertex form is something like this. You have a factor in front, x minus h all squared plus k. And the way to get the vertex form is completing the square. So if you don't know how to complete the square yet, maybe watch the video about how to complete the square, and that will help you. An example of this is x plus 2 all squared plus 1. Okay, so now when you have these forms, sometimes you are given one, but you need to convert it to the other. So the way to get from the standard form to the factored form is by factoring. And then if you want to get from the factored form to the standard form, you just expand this expression. And after, simplify. So expand and simplify. Okay. And then up here, I already mentioned it, to get to the vertex form, it's completing the square. Square. And then to get from the vertex to the standard form, it's the same as the factored forms, just expand and simplify again. Okay. So let's do some examples. So let's say you are given x minus 2 times x minus 4. So now if you want to get to the standard form, you expand and simplify it, which means we can apply the rule where you multiply these, and then after multiply these, or you can use the sum product rule. So that will be x squared minus 4x minus 2x plus 8. Now simplify, and that's equal to x squared minus 6x plus 8. Okay, so now you have the standard form, and if you want to go from the standard form to the vertex form, you have to complete the square now. So in the middle we have a negative 6x, which means that our factor, here the h, our h has to be 3. So x minus 3 all squared plus k. So we don't know what k is yet, and we have to still make sure that we take care of this 8 over here. So these parentheses, if we calculate it, is x squared minus 6x plus 9, and that's just this expression here expanded and simplified. So now we have to make sure that the 9 is not added. We just add 0 because we don't want to change the expression. So we have to subtract it again. And after, just add the 8. So this expression here, parentheses, that's the x minus 3 all squared. And then our k has to be minus 9 plus 8, which is minus 1. And that's our vertex form. And the same works if you want to go from the vertex form to the other side. You just expand and simplify after you factor it to get to the factored form. So now let's talk about why we need those different forms. So your standard form is good if you want to, for example, use the quadratic formula, but when it comes to graphing, it's easier if you have your equation in the factored form or the vertex form. So if we have a graph over here, x minus 2 and x minus 4, those will automatically give us the x-intercepts. An x-intercept just means that it's intercepting somewhere on the x-axis, and that also means that y is equal to 0. So when y is equal to 0, in this example here, this expression here, which is equal to y is equal to x minus 1 times x minus 2 times x minus 4. So that has to equal to 0 now to find the x-intercept. Well, when is this expression equal to 0? It's equal to 0 when either these first parentheses are 0 or the second one. The first ones are equal to 0 when x equal to 2. Because 2 minus 2 is 0. And this one is equal to 0 when x is equal to 4. So now we know that the x-intercepts are at x equals to 2 and x equals to 4. So 1, 2, 4. This is the x-axis, the y-axis. 1. So here is 2 and here's 4. So those are our intercepts. Now, because this expression doesn't have any factor of a in front of it, there's no -1 or 2 or anything else in front, it's just a regular parabola. So we can just draw a parabola through the intercepts. And that's how you can graph a parabola based on the factored form. And our second option is graphing the parabola based on the vertex form. So in this one here, we are given the vertex Vertex form, the x minus 3 all squared minus 1. Minus 1 determines the vertical shift. So we know, let's call this x-axis and y-axis. We know that the parabola is shifted -1 downwards. And minus 3 means there's a horizontal shift of 3 to the right. So that means we are over here at 3. And this is our minimum point. 3 to the right and 1 down. And from here, we can again draw the parabola. Maybe make it a little prettier, but that didn't work so well. Okay. So that's based on the vertex form. And you will notice that those two are the same parabola, just drawn with different forms. And it's important that you know both, because sometimes you're given a parabola and you have to find out the equation based on the parabola. Well, if you can easily read off the minimum point, you need to use the vertex form. If you can look at the equation and see the intercepts, the x-intercepts, it's easier to use the factored form. But sometimes you can see the x-intercepts, but you're not quite sure where the minimum point is. Or you can see the minimum point and you can't read where the x-intercept is. And that's why you should learn both forms.